Okay, so how do we add two non-parallel forces using the parallelogram method? Right, I've written down the steps at the side here, but I highly suggest you write it in your physics notebook. Reason being, it's a lot easier for you to refer for subsequent questions. Okay, I just wrote it here so that it's easy to do this question now. The first step that you should do is that I really encourage you to do is estimate the resultant, estimate what the resultant force would look like. Okay, so given the question, so you have this dude Jeremy being pulled upwards 3 newtons, to the right 4 newtons. Okay, I very kindly already gave you a diagram with the arrows roughly the correct length, meaning the 4 newtons force is actually a bit longer than the 3 newtons force. So you can kind of really estimate where the resultant force would be, right? Like what we did earlier with the intuition. Intuitively, you kind of know that the resultant force, if these forces look like this, the resultant force looks something like this. Sorry, looks something like this, right? So you kind of have an end in mind. This is what roughly, if your resultant force doesn't look like this, then we did something wrong, right? And of course, for any other combination, this is a very nice 90-degree. If it looks something like this, you already know intuitively that the force will always be somewhere between these two forces, right? If you pull here and here, there's no way you're going to end up flying backwards, right? So always just imagine if two people pull you like this, where will you fly, right? There's no way you're going to fly backwards, you're going to fly forward, something like this. If you have a very big angle like this, there's still no way that you're going to fly backwards. You're going to fly somewhere between these two forces. So you're going to fly, this force is a bit stronger, so maybe a bit closer to the bottom, so maybe something like this, right? So just by intuition, you should be able to guess where the resultant force is. Do a quick sketch at the side so that you know you have the end in mind. Okay, so the first step is estimate the resultant. It should always be somewhere between the two forces. Okay, so what is a scale diagram? Okay, a scale diagram means that the length will be directly proportional to the force, the size of the force, meaning we will need a scale. Okay, so the first step of drawing a scale diagram is always, first you need to choose a suitable scale. So just write scale, right? After you write the scale, so you just choose a scale. How do you choose a scale? Okay, so the scale will look something like, for example, a simple scale is say 1 cm. 1 cm represents 1 newtons. Okay, this is a simple scale, which means if I were to draw a line like this that is 3 cm long, if it's 3 cm long, how big is this force? Okay, if it's 3 cm long, it's 3 newtons because 1 cm represents 1 newton, so 3 cm is 3 newtons, right? But here's the problem. What is a suitable scale? Basically, you need to draw the diagram as big as possible so that you will minimize error. Okay, so given the space you have, the rule of thumb is always that your diagram must fill at least half of the space provided. Okay, so what will my diagram look like? Okay, now you don't know anything about it, but basically it's going to look something like this. Okay, so you need to do a bit of planning. You need to see how much space you have. So in this case, to draw a suitably big diagram with this amount of space, I'm gonna go with something like 1 cm represents 0.5 newtons. Okay, or basically 1 newton will be 2 cm. Okay, so 1 cm represents 0.5 newtons. In general, you always write 1 cm represents how many newtons. Okay, so for now you can just use this scale and copy along first. After a while, we'll get used to this scale thing. Okay, so choose a suitable scale. After you choose a scale, you draw the crosshair, the origin. Okay, so the diagram is going to look something like this. So I want my origin to be somewhere below. Okay, so let's say I draw the origin somewhere here. Okay, when you draw the origin, what you're gonna do is first you draw a horizontal line, dotted line. Okay, draw a horizontal. You do this in pencil, please. Okay, draw a horizontal dotted line. Then you okay, you need to draw a perpendicular line downwards, down the middle, down the the middle of this to draw a perpendicular line. Okay, so life hacks. Okay, of course by right you're supposed to use a protractor or whatever, right? But if you can see that I have these markers here, right? These markers are already perpendicular to the edge of the ruler. So if I were to align the marker such that it is perfectly in line with my dotted line, can you see? I'm going to align the 5 cm mark. I'm going to align it perfectly with the line, the dotted line. So if I align it perfectly with the dotted line, then I can say that this edge is more or less perpendicular, like quite accurately it's perpendicular. Okay, so when you draw your crosshair, you can just use this method to draw the perpendicular crosshair. Okay, so look something like this. This is your origin. You can mark it for O. Okay, so this is where all your forces are going to start from. Okay, I think I'm going to have a bit of a problem here, but it's okay. Okay, so draw your crosshair origin. So we're done with estimate resultant, choose a suitable scale, draw the crosshair. So let me zoom back out. Okay, so your paper should look something like this. Okay, next, draw the forces that they are given to you in the question, the two forces from the origin. Okay, and you need to draw it at the correct angle. So the question tells you that these two forces, 3 newtons and 4 newtons, are 90 degrees to one another. So you just basically need to draw exactly like what this looks like. Okay, this guy Jeremy is being put 4 newtons horizontally, 3 newtons vertically. So we're going to do just that. From here, because this is horizontal and vertical, is very easy. So let's just draw horizontal and vertical first. So the horizontal line is going to be from the origin, okay, 4 newtons. 4 newtons is how many cm? Right? So let's have a working column at the side here. Okay, if 1 cm represents 0.5 newtons, okay, then okay, maybe you want to flip that around, sorry. So 0.5 newton represents 1 cm, then 1 newton will represent 2 cm. So if 1 newton is 2 cm, 4 newtons will be 8 cm. Okay, so you're going to draw an 8 cm line, horizontal line, to represent the 4 newton force from the origin. Okay, so now this origin is like where Jeremy is standing, where Jeremy is. Okay, so you draw this 8 cm line and exactly at 8 cm. Okay, of course you should draw a bit more accurately than me. And then you must remember to put in the arrowhead to show that it's a force and the direction of the force. Okay, so you put in the arrowhead and you must label the force. So this force is 4 newtons. Okay, so you draw the force 8 cm based on the scale, put in the arrowhead and write down the force. Okay, next force you're going to draw is the vertical force, that's 3 newtons. So for 3 newtons, then it will be 6 cm. So 6 cm. Okay, so this is bad planning on my part. You shouldn't write the scale there, you should write the scale at the side or at the bottom. But anyway, I'm just going to draw it. So this is vertical. Okay, remember to put in the arrowhead and then write 3 newtons. Okay, of course you have measured this because this is horizontal and vertical. We didn't measure any angles because we already did it in the origin. So you need to mark the angle between the forces. Okay, so draw the forces from origin. Make sure you remember to label the forces, to put in the arrows, and to mark the angle. Okay, it should be drawn. The forces should be drawn with a solid line. Okay, so this should be drawn with a solid line or solid arrow. Okay. Next, now you construct your parallelogram. Okay, so you already know your resultant force is going to go across somewhere here, right? Exactly where? How we're going to do that is we're going to use a parallelogram to find out. So now you just construct a parallelogram. I've already taught you how to do that in the previous video. So basically, align your sail with the line that you want to draw a parallel line for. Okay, so I'm going to align the sail here. I'm going to put in the boat, hold the boat steady, and slide the sail. Where do I slide it to? Right, parallelogram, so this is one side, I must slide it to the end of the other side, and then I want to draw a line up. Okay, so what I'm going to do is draw a dotted line from here up. Okay, I'm just going to draw a long dotted line. Doesn't matter where to stop, I just draw it a bit longer first. Okay, so now I have dotted line up. Next, I want to draw a parallel line for this one. So again, I align the sail. Okay, I'm going to turn the paper so it's easier for you to follow. I align the sail with the line that I want to draw a parallel line for. Okay, it will be helpful to make the base of this sail a bit lower than the starting point. Okay, if not, it's very hard for you to draw later. So I align the sail. I put in the boat. Then make sure the boat is flushed with the sail. Then I slide the sail. Okay, I slide the sail across until the tip of this side of the parallelogram, or this force. Okay, once I reach the tip of the force, I stop, and then I hold the sail steady, and I draw a dotted line all the way down. Okay. Actually, life hack, you can just draw a straight line and then you erase a few times here and there, then you get a dotted line. Okay, but make sure you don't forget to erase and make it a dotted line. Okay. So after you have done this, you will have constructed your parallelogram. In this case, it is a rectangle because the angle is 90 degrees. Okay. So with this, you see that you have an intersection here, right? So if your line doesn't really intersect properly, you can just use a ruler and extend it a bit to make sure that it intersects. So this is your corner. Okay, so now where is your resultant going to be? Okay, so draw forces done, construct parallelogram done. Next is step 6, draw the resultant force. The resultant is going to be from the origin to the opposite corner of your parallelogram. Okay, so from the origin to the opposite corner, you just take a ruler and join from the origin to the opposite corner. The resultant will be drawn with a solid line. Okay, I didn't do that very accurately, but please do that more accurately than me. Okay, so join it accurately to the opposite corner, then you put in a solid line, you put in a double arrow head. Okay, a double arrow head to represent the resultant force. Okay, this is very important. The resultant force must be a double arrow head. Okay, and it must end at the corner. So, how do you find out what is the resultant force? Basically, now you measure and you find out the length. Right, and I measure it and I see that my length is 10 cm. Okay, yours should be exactly the same if you drew it correctly. Okay, so it is 10 cm. Whether you write 10 cm or whatever, it's fine. So you can just write 10 cm. So you calculate 10 cm. So if 1 cm represents 0.5 newtons, 10 cm will be, okay, this one you should do in pen. So 10 cm will be 5 newtons. So this is 5 newtons. Okay, but of course, a force has magnitude and direction. So you also need the direction. So how you measure the direction is you put your protractor at the origin. Okay, so you measure from the horizontal. So this is 0. 0, I go up to 35, 36, 37. Okay, 37 degrees. So you're right, 37 degrees. Okay, so your final answer will be, the resultant force is 5 newtons, 37 degrees from the horizontal. Okay, this is how you always write the direction of it. You always write how many degrees it is from the horizontal. Okay, so it's 37 degrees from the horizontal. Okay, and that is how you do a basic simple vector diagram.